Hello, you all, guys. Thank you very much to be here. This talk is starting some years ago when I start with my community talks, and it evolved a lot during the years. And today, this will be more or less the agenda. I will start with a quick introduction, and then we will see first the networking basics of the AWS serverless service, and then we will see the option that AWS offers with some use cases. And we will go more deeper in some best practice about security measures, scalability planning, and some takeaways about all this. So a quick introduction about me. I'm Enrico, as you can see. As you can also hear, I'm an Italian computer science engineer and co-founder and CTO at Hiop. And I have some experience with the data fields from research point of view and also in some scale-up. And I'm also a AWS community builder in serverless category. 5 years ago, I founded with my two friends, Giacomo and Vincenzo, Hiop. Basically, we, from different roles, business, technical, and consulting roles, we started to think about how to recreate the data infrastructure for this new AI era. Before it was machine learning, now it's AI, but yes. Basically, the idea behind Hiop is to provide a serverless cloud SaaS tool, that introduces this data logistic concept that is like traditional logistic. You provide the information in order to connect, and then the engine provides you the infrastructure and everything that you need to move your data or enrich your data. We will see why this is relevant, because this inspired the talks about the serverless networking and everything. But let's start on why networking and security matters a lot, especially in serverless. Before my talk, there was the Yang Kui talk in the main stage that was very interesting because it introduced some of the concepts about this. The first one is, of course, that serverless doesn't mean that there are no operations. This means that there is an automatically provider of infrastructure, of tools, and all of this, but you still have to manage some operational information in order to scale at the end. Because you can start with the serverless is nice, but then it provides a lot of hidden complexity. Connecting VPCs, security group, made private subnets to communicate. This is also something that matters a lot, also in serverless context. And of course, there is an high stakes. Imagine that you open a wrong port in a security group and made publicly accessible some important informations, or you misconfigure a VPC endpoint, and then at this point there will be a high cost on what you are building. So this is very important, and I hope that today we will turn these invisible layers into some specific actions and best practice that you can apply immediately in your projects and in your product. So let's start with a quick introduction about the networking basics of the standard AWS, like the VPCs, and then we will go more deeper in the principal service, serverless service. What is a VPC? I think that you already know, some of you already know, is an isolated virtual network, basically within your AWS account. Every VPC lives inside a region, and every region, that is the physical place where the AWS servers are stored, contains different availability zones that I don't want to go deep on these concepts, but represent the physical place inside the region that where your VPC is effectively created. Inside the VPCs, you create the subnets. The subnets are basically could be public or private, and what is differentiate between private and public is the internet gateway. Because if you create an internet gateway and configure the access to this internet gateway, then the resources that are deployed inside the public subnet, inside this subnet, could communicate easily with the internet. In the private ones, there is the resources could also communicate directly between internet, but there is no an internet gateway. There is a NAT gateway, an IT gateway, that it's used in order to provide public access. Another important concept in the VPC are the route tables, because are just like a table where you define the routes of your network traffic. So basically, you are saying in this example from the private subnet, when you are going to 0.0.0/0, go to the NAT gateway that then redirect the traffic to the internet gateway, and you can go on the internet. The last important basics to mention are the ENI, the Elastic Network Interface. Basically, are the interfaces that are connected to specific services in AWS and provide them like IP addresses, but in general, all the network information that a specific service needs to access, to have networking and communication between other services. So, in order to wrap up, you can see the final image like there is an ECS Fargate that is communicating to an Aurora RDS in another private subnet, and in the route tables you are specifying like the path that every service needs to, every subnet needs to have in order to communicate to other IP addresses. Another important concept are the firewalls. How AWS converted the traditional firewalls concept inside their cloud environments. First with network ACLs, access list, that basically are firewalls that are at subnet levels, stateless, and also have numbered entries, like a traditional firewall. You could allow or deny, basically ordered by the lowest number first, specific IP addresses or IP ranges, and specific ports. The other that is most common, because usually network access list is something that comes to default, it's not always controlled. Security group instead that are not at subnet level, but are on ENI level or instance level to be more specific, are stateful firewalls, so they are not stateless, and they don't have a specific order in order to perform the operation and to block. They just have an allow rules, and where you can specify also IP addresses and ranges and ports, and are very fine-grained access. So usually why you are not working a lot with network access list, because by default you allow all the traffics in your subnet, and then you go more in details, more fine-grained in the security groups. So this is more or less the concept of firewalls in AWS. Let's see some of the serverless service and how they manage the networking. These are two examples of Lambda with VPC and without VPC. Usually, when you start a Lambda and you didn't provide VPC access and everything, there is the left scenario. So there is a Lambda can directly go to the internet, and you can write your code and execute your code. But then, when, for example, you need to having a specific IP addresses to the Lambda for going on the internet, or communicate with private subnet or private instances, like in this example, an RDS, and giving also security groups information in order to, as I said before, to fine-grain the access to the AWS Lambda, you need to set up a VPC or to attach your Lambda to a VPC. As you can see, this creates an attachment on a network interface of your Lambda to the VPC you are selecting. We will see that this is important for many reasons, both for performances, but also for quotas limits that AWS have on these specific virtual devices. Some suggestion when you are building Lambdas with VPCs is to always configure multi-availability zone subnets in order to provide high availability to your Lambda. And also, as always, in the security group, provide the least privilege access. API gateway, another very famous and important serverless components of the AWS environment. Also have a public and a private path that you can follow when you are building and you are using it. And depends a lot on the endpoint that you are using when you are configuring API gateway. So, for example, if you are configuring regional or edge-optimized endpoint, you will follow the public path. So, usually the traditional integration of this is that there is a Lambda proxy that straightforward the request you are doing to the API. The difference between regional and edge optimized is that regional is low latency and is specific to a single region, it have high performance in general. And then the edge optimized have CloudFront, that is like a front door for global caching, and also it depends on the use case, it could improve or reduce the performances. And is distributed all around the AWS environment, and it's not in a specific region. Then there are the private types. The private types are always used for inside communication between your services, for example, when you want to expose, for example, as you can see, a Fargate application or a Fargate API internally, and by securing it with some specific components, extra components. And this is done with VPC link and VPC endpoint that we will see later more in details. Some important best practice when you are building API gateway, always use WAF, that is a firewall that is blocking the common attacks that when you are exposing your APIs, and also let you control the rate limit in order to avoid massive requests to your API. Also, try to use the authorizers. There is a simple JVT that you can configure, but also you can integrate more specifically with other Lambdas or Cognito request. Service, sorry. And then you can specify resource policies for your API gateway APIs by restricting them on a specific IP addresses, and as I said, by adding VPC endpoint or EAM principal that needs to call the specific APIs. Let's go with another service that is Fargate, AWS Fargate. Represent the concept of an EC2 instance, but with containers. The difference of Fargate used in serverless way between using the traditional way with an EC2 is basically this one, that the networking mode is very different. Because when you when you use Fargate with an EC2, you use all the networking logic of a specific EC2. But when you are using it in a serverless way, basically you have this predefined AWS VPC networking mode that made every task to act as an EC2 instance. So with a specific IP address, with a specific security group, and with its own network interface, elastic network interface. So as you can see in the example, you can apply, as I said, security groups directly to each task. And also you can use service discovery in combination with the Cloud Map service in order to give specific name to your services and tasks. So in this example, you can see API.internal and app.internal. And you can use this DNS, private DNS, in order to communicate easily and also to distribute like your Fargate services in multiple instances, in multiple tasks also if you need redundancy, for example, but by using a specific DNS, for example. So, what are the ways that AWS offers us in order to provide connectivity? Let's start with a simple use case. You have a Lambda in your AWS account and is deployed inside a private subnet in your VPCs. Then you need to retrieve data from some RDS Aurora database that is deployed in another private subnet, but in a different account, and so in a different VPCs. So more or less this is the scenario. There are 2 accounts, 2 VPCs, and 2 resources in a private subnet. So what we can do in order to provide connectivity between these 2 services? The first way is the simplest one, is called VPC peering. Basically, it's just a connection between the 2 VPCs that you create in one of the accounts, then you confirm in the other account, and then by setting up the route tables, you can create private connectivities and you can call the 2 services using the private IP addresses. But there are some limitations on this. It's very simple, but very limited on a specific use case. Because, of course, it works with the resources that are distributed inside the VPCs and the subnet. But also, there is a CIDR overlap. So you cannot use the same IP addresses inside the VPCs to create a VPC peering connection. In what sense? Imagine that you have a 10.0.0.0/16 VPC range, IP range in one of the VPC. If there is at least one of the IP addresses inside this range that have a collision in the other VPCs, imagine 10.0.0.1/16, you will not be able to perform VPC peering. So, how AWS solved this? With another service, of course, that is more secure and also more customizable, let's say. That is PrivateLink. PrivateLink allows also private connectivity in different accounts, in different VPCs, but also is very nice because let you also have control also when there are collision of IP addresses between the 2 VPCs. How is doing that? Basically, it's using VPC endpoint from one side and then network load balancing to perform like a double NAT connection, double NIT connection, and is simulating the local addresses. So basically, as you can see in the consumer account and in the provider account, you will have a specific DNS and you will use it as a private DNS without caring a lot about the IP addresses that are behind and that could have a collision. So let's see more in details PrivateLink because it's interesting. First, by starting with the network load balancer role. The network load balancer role in the provider account acts as a front door for PrivateLink, basically, enable the cross VPC service and exposure, and also offer high availability, scalability, and IP preservation, as I mentioned before. So you can see in the image the network load balancer is in the provider VPCs, and multiple customers can connect to the network load balancer thanks to the PrivateLink exposure. Then there are the VPC endpoints that act, as we can see, in the consumer VPCs and in the consumer service. There are 2 types of VPC endpoints. VPC endpoints are virtual horizontally devices, a lot of buzzwords, scalable, redundant, highly available. And basically, there are 2 types of VPC endpoints. The first, that are the ones that we need for the PrivateLink connection, are the interface one, and are used, as I say, to enable PrivateLink, and they support a large number of AWS services. Here you can see some of them: API Gateway, CloudFormation, CloudWatch, etc. But then there are gateway VPC endpoints that are used for specific services that are not distributed inside a VPC, like DynamoDB, S3, for example. And VPC endpoint, the gateway VPC endpoints allow you to contact S3 or DynamoDB inside your VPCs, inside your AWS account in a private way. Because usually what happens, this is thanks to AWS Fundamentals guy for this nice. What happens, you can see when you call an S3 bucket or DynamoDB, you are always going on the NAT gateway. if you are on the private subnet, then internet gateway, internet, and you go to S3. But if you use a gateway endpoint, you can see you can call this and go directly to S3 bucket. This is very important because the NAT gateway egress cost, you are always paying for the NAT gateway egress cost. And the cost of using gateway endpoint when you have the needs in a private service to call an S3 bucket or another service that is supported by VPC gateway, it's very important, especially if you have a large amount of data. So, how is our use case after these two, by using these two services? We can use, I created an architecture with both solutions. As you can see, you can combine and use VPC peering when you have control over the network IP addresses, over the VPC and subnet IP addresses. Usually, you can use for shared services with partners or internal communication, but in different accounts. This could be useful for this, but it depends on the use case, of course. Then you use PrivateLink when you, for example, want to connect to different customers privately, so you don't have control about the VPC IP range. And for example, in Hiop, we are using in order to communicate privately with other AWS accounts. The benefits of using one or the other solution are, of course, that by private communication, you can define security boundaries, you can easily scale, and also there is a very isolation on the tenant that is connecting to your service and to your VPC. Let's go with another use case. Very similar. You have your Lambda in your VPC, in your private subnet, the same. But this time, the database is not in another AWS account, but is in another cloud provider service, or is on-premise, in an on-premise network. So the situation is like this. You have always your Lambda. This time, I also added a Fargate service also deployed in a separate VPC. And you have your database in your on-premise or other cloud providers, imagine Azure or Google Cloud network. What AWS offers in order to solve this use case is a service called site-to-site VPN. Basically, a site-to-site VPN is a service that enables secure communication and secure IPsec VPN connectivity between two users' cloud infrastructure or on-premise and AWS. As you can see in the image, it's composed by three main services. The transit gateway, as you can see, is the first one. That is an alternative also to VPC peering. We will see just in the next slide how this is working. And basically, it's a network hub for AWS VPCs. Then there is the customer gateway on the other side that represents the VPN device, like a router, or another type of components in different clouds, for example, but represent the user device and the user network. And then there is the VPN connection that is just act as a configuration layer and allows you to create multiple tunnels, but we will see it later. So, for the transit gateway, basically, some information is centralized hub, allow you to connect multiple VPCs, VPN connection, VPC peering connection, and basically the main differences between VPC peering is, of course, is also in the name, the transitivity of the communication, because you can, in the transit gateway, you remember before I said that in the VPC peering, you have to configure the route tables of both subnets in order to make them communicate. The transit gateway have a specific route table itself where you can create this transitive between the different networks. So it's very nice and it's important because allow you a lot of scalability, but also cost and efficiency because you can monitor easily all the communication if all your networks are mapped inside the transit gateway. So the common use case is when you have a lot of different accounts, maybe in an AWS organization, or you have an hybrid cloud architecture, or you want to centralize all specific service in for logging, authentication, or other reasons, for example. So with the transit gateway, our use case is starting to be more efficient like this. So now the two VPCs are connected. And then we use the customer gateway. The customer gateway, as I said, represents the on-premise VPN device in an AWS configuration, works with the transit gateway or with other component that we will not talk today, that is the virtual private gateway, and support redundancy, so support multiple tunnels and automatically change the communication based on the availability of the specific tunnel. So, as you can see, our use case now with the customer gateway have two tunnels. The transit gateway makes the communication with the customer gateway with the information that are stored in the VPN connection, and there are two tunnels that are used, the first by default, and the second for redundancy in case there is a problem with the first tunnel. In this way, you can communicate easily with another cloud or with an on-premise network. In general, there are a lot of VPC connectivity options. There is a nice white paper. If you search for Amazon VPC connectivity option in Google, you will find immediately, and offer this white paper all the possibilities that AWS have in order to create VPCs or, in general, networking communication between AWS cloud and other types of networks. Let's go with some advanced security measure, some details. I didn't prepare a use case for this, but maybe we can discuss it later if you have some idea about this. When you are communicating publicly, so not privately with your S3, for example, or with a different S3 that is in another account, for example, in a customer account, there is an easy way. You can create an IAM user in the other account, you get the access key, the access secret, and you access to the S3 bucket. Try to avoid this behavior because it's not very suggested. Instead, try to do like this. You can use a service that is called security token service and a specific API of security token service that is called assume role that allow you to define an IAM role and then assume the rights that role have in order to access to the S3 bucket. I made an example with S3 because it's the most common use case, but there are several ways to do this. And also there is the possibility to create this role in a dynamic way. So it's very interesting. And to limit the access using trusted policies of IAM role. So inheritance all the IAM role possibility, let's say. Some other security best practice is always to use TLS certificates and with Amazon Certificate Manager. That is super useful and it's free, basically. So Amazon, I don't think that Amazon charge for the creation of the certificate. Before it was just inside the AWS world, the AWS cloud, but now they started also to you can now download the certificates and use it in your own network. So it's very powerful now. In this way, you can enforce, of course, HTTPS everywhere. Try to always enforce in API gateway, load balancer, etc. You can use custom domains with the services, I said, and it's free. And you remember always to redirect HTTP traffic to HTTPS because some user can access to the HTTP. So remember always to redirect the traffic if you are configuring HTTPS. Try to require also client certification and two-way authentication when there are critical resources, when two critical resources have to communicate. And also try always to encrypt in both sides and in both connections. As you can see in the image, there are several steps that your data or your information or your service could communicate. Try always to enforce encryption. Secrets management, AWS offers two different services, Secrets Manager and Parameter Store. Imagine in this use case that you have a Lambda with environment variables. You can set up environment variables directly in the Lambda. Try to use these two AWS services, Secret Manager and Parameter Store, that is a specific service inside AWS System Manager. Basically, the main difference is that Secrets Manager also can provide you rotation of credential, automatically rotation of credential, tokens, etc. SSM Parameter Store, you can have the same behavior, but you have to write custom code. You have to connect several services like KMS, etc. So the best practice is to always provide the access to the least privilege information always in the EAM role, in this case, that is attached to the Lambda, and always try to encrypt the information also if it's encrypted automatically in both services. Regarding the scalability, Lambda concurrency and network resources. Before I showed you that when you are configuring VPCs with Lambda, there are network interfaces, elastic network interfaces. Remember always to, if you want to scale your Lambda with a lot of requests, with thousands and thousands of requests, to use these two possibilities that AWS offers you. The first is a reserver concurrency that basically ensures that you have enough IP addresses for your network interface, because there are limits on the network interface based on your VPC configuration or on AWS limit. And also use provisioned concurrency, because when you run a Lambda inside the VPCs, there is always an extra time in order to attach. Usually it's around 200 or 400 milliseconds, but it depends, it could depend. By using provisioned concurrency, you can pre-warm the network interfaces if you are providing like a speak or something, in order to accelerate the startup of the network interfaces. Regarding Fargate, remember always to also the same. If you are running multiple tasks, remember that every task has a network interface and private IP addresses. So remember it when you are creating your VPCs. And also you can, in different cases, automate the creation, the management of the security group in order to maintain isolation in the different tenants, especially during the scale events. And also in API Gateway, remember to use a usage plan to cap RPS for client, to cap the request for client, and use this security service, this firewall, in order to absorb the traffic and trying to avoid the common attacks that could happen in your public APIs. Last but not least, AWS have some limits, networking limits and quotas that you can see in this amazing page. They change by region, so I will not mention the specific, but for example, the every availability zone have 3,500 network interface limits. You can change it, but of course, remember when you are developing your application that there is this limit. And also, yes, when you are defining VPCs and subnets, there are addresses capacity. So remember always to think about the possible IP addresses that you could need when you are creating VPC and subnet, because changing later could be difficult. Another limit is the API gateway throughput, that is 10,000 limits and 5,000 burst request rate limit. You can raise all these limits, of course. And then there are also limits on the VPC endpoint count, basically. So, a quick recap of the takeaways. At the beginning, I talked about Hiop platform, that is, all this talk is based on the story that we used to develop Hiop. All the things that I shared today is something that we faced in these years by building the platform. Basically, as I said, there is the logistic platform, and then there are different locations, both on input and output, that can be used. Nowadays, thanks by applying what I shared today with you, we are able to perform this number, a lot, more than 30,000 delivery per month and more than 40 terabytes of data. We support several locations, SQL, NoSQL, and especially we provide 80% of time to live speed up by automatizing all these connections by the VPN, etc. And also, of course, AI agents can safely figure out and perform operations on data. Last slide, some actionable insight of this talk. Basically, remember always to design the VPC by thinking both on the root tables and the IP addresses that you will need. Audit frequently your network interface usage you can set up CloudWatch alarms. Implement VPC endpoint for your private communication of S3, DynamoDB, or other services that support VPC gateway endpoints. And also remember always to choose the right services for your connectivity needs. On the security part, remember always to enforce less privilege EAM roles. Apply security group in all the services with fine-grained rules, remember. Rotate all the secrets always. You can do with Secret Manager automatically, or you can create your custom logic for parameter store. And when you have to scale, always remember that there are some limitations that AWS limit you by using networking components. And in general, try to monitor also this. That's all. Thank you a lot. And there is this feedback QR code if you want to share your opinion and try me to improve this talk. So thank you again, and open to questions.